Hi everyone, here's a video on properties of quadratics in standard form. You can check it out in Chapter 5, Section 2 of your textbook. So, parabolas are symmetric curves. So we have an axis of symmetry, and it is the line that goes through the vertex of a parabola that divides the parabola into two congruent halves. So if you check out this picture right here, there's the parabola and there's a dotted line going through it. We don't graph that line, but it does exist. It's just the line that it divides it in half. It makes it symmetrical on each side. And you'll notice that it goes through the vertex of the parabola, which has a value of hk. So if we are looking at this equation, f of x equals -1/2 times x plus 5 squared minus 8. Remembering what we knew about transformations, this parabola has moved to the left 5. Another way you could think about this is if we set it up as x minus, remember in vertex form we have it set up as x minus h. So if we want to figure out what this is, to figure out the value of h, we know it's -5. And so because h is -5, and therefore the x value of the vertex is -5, the axis of symmetry is the vertical line x equals -5. So if we look at the graph of this, when we show the line x equal to -5, you can see that it goes through the vertex, and it is the symmetrical line x equals -5. So figuring out the axis of symmetry for this graph, x minus 3 squared plus 1, we know the graph has moved to the right 3, therefore the axis of symmetry is x equals 3. So looking at this graph, you can see the same thing. If we move the parabola to the right 3, the axis of symmetry is also moved to the right 3. Another useful form of writing quadratic functions is the standard form. The standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a does not equal 0. The coefficients a, b, and c can show properties of the graph of the function. You can determine these properties by expanding the vertex form. So remember, the vertex form is a times x minus h squared plus k. So x minus h squared is x minus h times x minus h. So if we multiply that out, we'll get x squared minus 2xh plus h squared. And then you'll see in the front that a will now distribute that across to each of them. So I'll have ax squared minus 2ah times x plus ah squared, and then they put it in parentheses, plus k. So if we group our terms together so that we have the first section, the second, and then the third, and we relate it back to what we started for our standard form, ax squared plus bx plus c, the a stayed the same, b became -2ah, and c became ah squared plus k. Maybe you'll want to rewind the video to check it out a little bit further, but for now let's keep going. So a in standard form is the same as it is in vertex form. It indicates whether a reflection or a vertical stretch or compression has been applied. So a, the number all the way in the front, means the same thing whether in standard form or vertex form. B is equal to -2ah. So if we wanted to solve for h, which remember is the x value of the vertex or the axis of symmetry, solving for h by dividing both sides by -2 over a, we'll get h equals b over -2a, and we could just pull the negative to the front, which is -b over 2a. So since x and h are the same thing for the vertex, the axis of symmetry, or the x value for the vertex, the formula for that is x equals -b over 2a. And the b and the a, again, come from the a and the b up here in the top for the standard form, the red and the blue letters. And then finally c, it's the same value given by the vertex form of f when x equals 0. So in other words, if we take 0 and we plug it in to our function up here for x, we'll have a times 0 plus b times 0 plus c. And the only thing that's not 0 here is c. So if we plug 0 in, then the value of c will be our y-intercept, since a y-intercept has a value of 0. I hope you're not feeling like this right now, a little bit confused, overwhelmed. Stick with it for just a second. Let's simplify that a little bit. So the properties of a parabola. For f of x equal to ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0, the parabola has these properties. So here's all of that previous information simplified. So looking at a at the very front of ax squared, if it is positive, then it opens upward. If it is negative, it opens downward. The axis of symmetry is the vertical line x equals negative b over 2a. The vertex is the point negative b over 2a. In other words, the same value we got from the axis of symmetry. So once we know the axis of symmetry, you plug that in for the x value of the vertex, since the axis of symmetry goes through the vertex. And then we just take that number and plug it back into the equation to get the y value. And then the y-intercept is just the last number, the plus c. So let's look at an example. F of x equals negative x squared minus 2x plus 3. So let's first determine whether the graph opens upward or downward. Well, you just have to look at what is in the very front of the whole equation for a. And a is negative, and because of that, the parabola will open downward. To find the axis of symmetry, remember that's x equals negative b over 2a. So b is negative 2, it's the coefficient, it's the middle term, divided by 2 times a, which is negative 1. So we'll have negative 2 divided by 2 times negative 1, which equals negative 1. Therefore, the axis of symmetry is the line x equals negative 1. So we did two things there. We've not only found the axis of symmetry, we also know the x value of the vertex. So the x value for the vertex is negative 1. To figure out the y value, plug it back into the equation you're given of negative x squared minus 2x plus 3. When you plug in negative 1, you'll get 4. Therefore, the vertex is at negative 1, 4. And then finally, the y-intercept. Remember, that's just the last value, c. So, because c equals 3, the y-intercept is 3, or the point 0, 3. If we were to graph this function, you could read this paragraph right here, or you can remember that we knew the vertex was negative 1, 4. And remember the 1, 3, 5 thing we talked about before? Oops. Well, the 1, 3, 5 still gets multiplied by a, which is negative 1. So now we'll go negative 1, negative 3, and negative 5. So once we know where the vertex is, we'll start out by going out 1, first down 1. The next time we go out 1, we'll go down 3. And the next time we went out 1, we would go down 5, and so on. So that would still get you the same points. Substituting any real value of x into a quadratic equation results in a real number. Therefore, the domain of any quadratic function is all real numbers. And then the range depends on the vertex and the direction that the parabola opens. So, the domain is always all real numbers for a quadratic equation, and the range depends on the direction and the vertex of the parabola. So, like we mentioned before, if the parabola opens upward, it has a minimum. If it opens downward, it has a maximum. And the range for a graph that opens upward would be y values greater than or equal to k, or the y value of the vertex. And the maximum for a graph that opens downward would be y is less than or equal to k, or the y value of the vertex. So remember that the minimum or maximum value is the y value of the vertex. It's not the ordered pair. So going back to that function we were looking at just a second ago, negative x minus 2x plus 3, we knew that the vertex was negative 1, 4. And because a was negative, the parabola opened downward. So to find the minimum or maximum value, because the graph opens downward, the graph has a maximum, and the value for the maximum is the y value at the vertex. So therefore, the maximum value is 4. If you need additional examples, check out Chapter 5, Section 2 of your textbook, and I'll see you later. Bye.